in today's lecture, what we will be doing is we will be learning more sums from the second formula of binomial expansion. The second formula, or the factorial formula, we have seen looks something like this, where the first term is always going to be 1. For the second term, it is n multiplied with the other term that we have beside 1, which is ax. And for the next term, we will have n minus 1 divided by 2 factorial, because there are 2 terms, and then ax to the power of 2. The next one is n minus 1, n minus 2. The power of n decreases. And then because we have 3 terms in here, 1, 2, 3. So we will have 3 factorial and a power of 3 over ax. So the formula for factorial continues like this, where the next term would be n. If we are asked to find the next term would be n minus 1, n minus 2, n minus 3. And because there are 4 terms, so divided by 4 factorial. The pattern is like this. Because we know 1 factorial is 1, so n divided by 1 factorial gives us the same thing. And then we will have ax to the power of 4. See, the pattern is 1 factorial, 2 factorial, 3 factorial, 4 factorial. Then we have n, and then n and n minus 1. Then we have n minus 1, n minus 2. Then we will have n minus 1, n minus 2, n minus 3. The power of ax is first 1, then 2, then 3, and then 4. Like this, it will continue. So the first example that we have is a very classic example for binomial expansions. The first question usually is that we have to expand something. So in the first part, we can see that we have to expand 1 plus x by 8 to the power of 8. So if we expand this, what will we get? We have 1 plus x by 8 to the power of 8. So we know from the factorial formula here, because the power is an integer. So if we want, we can also use the binomial theorem formula. But because we are learning the use of factorial formula, we will be using the factorial formula in here. So we have 1 plus nx. And then we have n minus 1 divided by 2 factorial. Then we have the ax to the power of 2. Then the next one will be 8 minus 1, 8 minus 2 divided by 1, 2, 3 factorial, and then x by 8 to the power of 3. How long we will continue it? Because we have a power of x cube in here, we will stop. We will continue up to the term in x cube. And then because there are other terms which we are not writing, so we give this plus and then 3 dots. Now what will we do? We will calculate. So 1 will be there as 1. We have nothing to calculate in here. Then x into 8 by x. We know how will we calculate this one? We will put everything in the calculator apart from x. So here we have x, it means we have 1x. So what will we put in the calculator? We will put 8 in the calculator. Then we will put multiplied with 1 by 8. So 8 multiplied with 1 by 8 from our calculators is going to give us 1 again. So we will write 1 into x, which is x whole. For the next term, we have 8 into 8 minus 1. We will put everything in the calculator as it is. We will put 2 factorial. The factorial sign in the calculator is over the inverse sign that you have, or in some calculators, the factorial sign is already given to you. So there is a button in your calculator that is something like this. So over this button, you have x factorial or 1 factorial or only the factorial sign given. So you will use that button in your calculator. So you put the factorial sign, and then here you have x by 8 whole square. So apart from x, what do we have in here? We have 1. We know because this is a term in x square, so we will have something into x square. So you will put 1 by 8 whole square in the calculator. And from there, you're going to get 7 by 16. So you are going to put 7 by 16 in your script. Then you have this whole term 8 into 8 minus 1 into 8 minus 2. So you're going to have 8 into 7 into 6 divided by 3 factorial. And then here you're going to have x by 8 whole cube. So beside x, we have 1. So we know we will have a term in x cube. So in the calculator, we will put, instead of x by 8, we will put 1 by 8 whole cube in the calculator. So if you put 1 by 8 whole cube in the calculator, you're going to get 7 by 64 in here. So this is our expansion. This is the answer to the first part of the question. Now for the second part, it is a very classic question. The part appears very often in exams where you are asked to estimate. Now for estimation, we first have to look for the term with the power. So we see that the term with the power is 1.02 to the power 6, and here it is 1 plus x by 8 to the power of 8. So because we are stating the question hence, which means we have to use this expansion somehow. So our target is to use this expansion that we have, the expansion that we got in here. Let's rewrite it. So we got 1 plus x by 8 to the power of 8 is equals to this expansion in here. So we have to use this expansion to figure out a value for 1.02 to the power of 6. So we will first check whether we have the powers same or not. Do we have the powers same? No, we don't. Here we have a power of 8 and here we have a power of 6. If we have the same power, then our task is easier. We don't need to match the powers. But if the powers are not same, then the math becomes a bit lengthy where we have to match the powers. If the powers are not same, we can start the math right away. If the powers are same, we can start the math right away. So what do we do in here? We have to first make the powers same. So we have to somehow make 1 plus x by 8 to the power of 8, the power of 6, because we are concerned with the power of 6. So we have to change this power. Now what do? We have to change this 8 into power of 6. So we have to change this 8 into 6. So what we will do is, we already have an 8 in here. What we do is, we multiply by 6 by 8. Because if we write 6 in here, then what will happen to this 8? We need a power of 6. So what did we do? We multiplied this side. We took a power of 6 by 8 on this side. If we take the power of 6 by 8, what happens? If we take a power of 6 by 8 on this side, then it means we have to take a power of 6 by 8 on this side also. So we have taken a power of 6 by 8 on both sides. What does this do to us? This helps to neutralize the two powers, because we know that if we have two powers over the same number, if we have two powers over the same number, the powers get multiplied. So 8 into 6 by 8 is going to give us 6, which we need. So we change the power in here. After we change the power, what happens? On this side, we get 1 plus x by 8 to the power of 6. And on this side, we have 1 plus x plus 7 by 16 x squared plus 7 by 64 x cube to the power of 6 by 8. Okay. So now we have the powers same. Now what will we do? Now in order to find out the value of 1.02 in place of x, we need to put something so that we know that we can proceed the sum. So what will we do? So the power of 6 is over here. So we will equate these two. In this side, we have 1 plus x by 8 to the power of 6. And on that side, we have 1.02 to the power of 6. So what is the value of x that we need to put in here to find the estimate? So if we equate both of these, we get 1 plus x by 8 is equals to 1.02. From there, we can solve for x. So we will get x by 8 is equals to 0.02 because this one goes to the other side and gets subtracted. So now 8 will be multiplied with 0.02 and we get 0.16. So what is the value of x that we need to substitute on the other side? We need to substitute 0.16 to the other side. So let us do that. So copy it down. So in place of x, we are going to put 0.16. So if we put 0.16 in here, we know that we are going to get 1.02 because we just saw that with the value of x as 0.16, we get 1.02 to the power of 6. So we are going to write that in here directly. So we have 1.02 to the power of 6. And this gives us, we know we have to substitute 0.16 in place of x. So we are going to substitute 0.16 in place of x. So we put 0.16 in place of 6 x everywhere. So now if we calculate, what do we get? We are going to get from here 1.171648. This entire thing you put in your calculator and you get this to the power of 6 by 8. Now you put the power of 6 by 8 over this one in your calculators and you are going to get 1.126154,215. Now, in the question, the accuracy that you have to give your answer to will be mentioned. It will be mentioned that give your answers to this much significant figure. If it says 3 significant figures, then you give your answer till 1.12. If it says 5 significant figures, then you give 1.1262. Like this. If nothing is mentioned, you give the whole answer. It's all right. Now, if you check from your calculator, if you put 1.02 to the power 6 in your calculator, you are going to see from calculator, the exact answer comes as 1.126162,419. So you can see that up to 5 significant figures, the estimate that we have found out is accurate. If you have taken more number of terms after the term in x cube, if we have taken the term in x to the power 4, the answer would have been more accurate. If we have considered the term in x to the power of 5, then the answer would have been more accurate. So let's do a quick recap of whatever we have done in here. So in here, what we can see is that we are asked to expand this. So we have the simple formula given. So we know the formula, we put that down in here and we get a result. Then in the next part of the question, it says that you have to obtain an estimate, which is a very common question. If you are asked to find the estimate, what do? You check for the powers first. So, and we equate the terms in power. That is our first task. What we can see here is that the powers are different. If the powers were same, we would have started, or we would have done this equating part in the very beginning of the question. But we can see that the powers are not same in here. In the question, we are asked to figure out the estimate for 1.02 to the power of 6. The estimate said 1.02 to the power of 6. But the question that we have here is 1 plus x by 8 to the power of 8. So what we did here was first we equate the powers. We first made the powers same. How did we make the powers same? We put the entire thing to the power of 6 by 8. 6 was the required power. So we put 6 in here as power. But we see that we have 8 in here. So if we take our calculation to the next step and the powers get multiplied, we are going to get 8 into 6, which is the power of 48. But we want the power of 6. So what did we do? We divided the power by 8. So now we know that this case results in the powers to get multiplied and we get 8 into 6 by 8. So our power becomes 6, which is our desired result. So we know that we cannot certainly make one side of the equation to a certain power. We cannot raise this, right? So we have to raise both powers on both the sides. We raise the powers on both the sides and we got something like this on the left hand side, which is the required part. Now the powers on the left hand side have been made equal. So we will now find out what value of x we need to substitute. Our first thing is to check whether the powers are same or not. Whether the powers are same or not. If they are not same, we will need to make the powers same. Then we will substitute the value of x. What is the value of x that we are going to substitute? We found that out by equating the terms in power. Power related terms, we made them equal. And then from there, we found out that if we want to use the expansion, if you want to use the expansion for the estimate to find out an estimate, you have to substitute some value of x. So how will you find that one out? You equate the terms related to power. From there, you solved and found out that the value of x is 0.16. So you will just now substitute the value. Sometimes the value that you need to substitute is already given in the question. Sometimes it's not. When it is not given in the question, you need to substitute. So you substituted that value and you found this one out. So what do you do now? Your task now is very easy. You just put the value of x that you found out in these places and you continue your calculation. You put everything in the calculator and you got this result and then you raise that to power of 6 by 8 and you get an estimate. Now let's move on to the next sum. I hope this one was clear to you guys. In this math, what we see here is we need to find out the value of b and n. So for the finding out the value of b and n, the expansion is already given to us. So we will take the help of the expansion. What we will do here is we have 1 plus bx to the power of n already given to us. So we will try to expand this first. According to the expansion formula, we can see that the terms that we have here is the first, the second, and the third term. So we will expand this up to the 3 terms. So we know the first term is always 1. The next term is nx. So here, instead of ax, we have bx. So we will write n into bx. The next term would be n n minus 1 divided by 2 factorial into dx whole square. So if we simplify this down a bit, what do we get? We get 1 plus n dx plus this one. If we simplify, we have n minus 1 divided by 2 factorial means 2 from our calculators. We can easily write this, and then bx whole square would mean b square x square. So now let's compare. If we compare, what do we have? We have 1 in here, 1 in here. So nothing to compare really. And the next one, we have 2x in here and we have n dx in here. So 2x and n dx, if you compare, what do you get? You get that 2x is equals to n dx. So we can say that if we compare the terms in x, we get nb is equals to 2. So this is our first equation. And for the next one, what do we have in here? We have minus 3x squared. And here we have n minus 1 b square x square divided by 2. So if you compare this, what do you get? You have minus 3x squared is equals to n minus 1 divided by 2 b square x square. So removing the x square from both the sides because we are comparing these terms. So we are going to get minus 3 is equals to n minus 1 divided by 2, and then you get b squared in here. Now these two can easily go and get there multiplied. So everything is in one line. It's easier for us to comprehend that way. So 3 minus 3 into 2 is 6 is equals to n minus 1 into b squared. Now, in order to find out the value of b and x, we can see here that we have b squared in here. So we can, and n squared in here also. And there will be a term in n also. So instead, and there are two n's to substitute, but only one. So this is our second equation. So what we will do here is, we will make b subject from here. So we get b is equals to 2 by n. This is our third equation, and we will substitute that in this equation. So if we substitute, what do we get? It's normal simultaneous equation solving. So if we substitute, we get minus 6 is equals to n minus 1, and in place of b square, we will write 2 by n whole square. So we get minus 6 is equals to n minus 1 into 2 square. This square is over the whole thing. So it means the square is over both 2 and n. So 2 square is 4 divided by n square. So in here, we have n, and here we have n square. So we can cancel one n out. So this n will get cancelled, and here we will only have n. We won't have any square term. So we will get minus 6 is equals to n minus 1 into 4 in here, and then there is n in the denominator. So now if n is in the denominator, we can definitely take that in here, and then everything will come into one line. So it's easier for us to comprehend that way. And we get minus 6n in this side, and in this side, if we multiply the numerators, what do we get? 4 into n, which gives us 4n minus 4. So from here, we have minus 6n minus 4n is equals to minus 4. So 6 and 4, if you add this up, you get 10. So we have minus 10n is equals to minus 4. So we get the value of n as minus 4 divided by minus 10, which is going to give us, from our calculators, 2 by 5. So this is our value of n. And in order to find out the value of b, what do? We know that we have b is equals to 2 by n. So we will use this one. We know that b is equals to 2 by n. So substituting the value of n, we are going to get 2 by 2 by 5. So 2 divided by 2 by 5 from your calculators is going to give you 5 only. So that is our value of b. I hope this sum was clear. This isn't a very difficult one. All you need to do is learn some easy techniques for simplifying, and then you will be able to solve this. The hint that we will have to use the factorial formula is given in here. Here you see you have bx is less than 1 given. We know that this term less than 1 is a restriction in the factorial formula. We don't have these kinds of restrictions in the binomial theorem formula. So using this as a hint, we use the factorial formula. If the value of n is not mentioned as an integer, if it is mentioned as an integer, we can use the other formula, the binomial theorem formula, to find that one out, the value of n out. But if the value of n is not an integer, or it is not mentioned anywhere that it is an integer, it is always wise to use the factorial formula. I hope this sum was clear. And with this, we are done with the easier examples. In the next class or the next lecture that we have, we will see a more detailed example or